Hello, Math 10 students. This is Mrs. Parsons, and today we're going to be talking about congruence versus similarity. This is skill 19, so make sure that you have a piece of paper out ready to take notes. So in congruence, congruence means that they are the same size and the same shape. But when figures are similar, they are just the same shape and they may not be the same size. Congruence can be retained by rigid motions, and those rigid motions we are talking about are translations, rotations, or reflections. In similarity, you can get those by translations, rotations, reflections, or dilations. So the dilations is what makes it bigger or smaller, which is why they may not be the same size. In congruent figures, corresponding sides are congruent and corresponding angles are congruent. But in similar figures, corresponding sides are proportional and corresponding angles are congruent. So in this first example, we have figure ABCD, and then we have figure GHIJK, and we're trying to figure out whether they are congruent or similar. So if I was to find out the transformations that happen, I can see that it was rotated this way, but it also has a dilation, which made it bigger. So we know that since they are the same shape but not the same size, that this is a similar figure because both rigid motions and dilations were used to map ABCDE to GHIJK. So if it was just rigid motion, it would have been congruent. But because we had a dilation that made it bigger, that just means that they are similar. In example 2, I have figure U and then figure V. So what transformations map figure U to figure V? Well, the first thing I had to do was step 1. And step 1 was a reflection. I reflected it over the y-axis. And then to get to figure V, step 2, I did a translation, which shifted it to the right. So these are both rigid motions. So figure U and figure V are congruent because only rigid motions were used to map figure U to figure V. So what transformations had to happen to map figure I to figure J? Well, we see that it was shifted, so we know that there is a translation there. But also there was a dilation because it got bigger. So figure I and figure J are not congruent because a non-rigid motion happened with that dilation. So since it was a dilation that occurred, it is not congruent and is most likely similar. Now we also write things called congruence statements. So here I have A, B, C, D is congruent to E, F, G, H. And it's very important in the way we write these because when we write them, they are in the same order where the corresponding parts are. So I know that angle A, since it is my first letter written, is congruent to my first letter written in the other figure. So I know angle A is congruent to angle E. Angle C, which is my third letter written, is congruent to angle G, because that is my third letter written. Angle D is going to be congruent to angle H, since that is my last letter. And then AB here is going to be congruent to EF. So I have the first two letters here and the first two letters here. DA. Okay, so we're going to go in the same order in my other figure. That has to be HE. And then HE is congruent to DA. Okay, so the congruent statement tells us a lot about the figures and where the corresponding parts are. Now I have ABCDEF. ABCDEF is congruent to figure, so we have to write the congruent statement. So you have to kind of visually see, if I were to stack these on top of each other, what would the corresponding parts be? So think about rotating this around so they line up together. So I got to find the corresponding part to A and list that first. So if I stack these on top of each other, I would get J. A and J would be my corresponding parts. And then B would correspond with K, and then all the way around the figure. So figure ABCDEF is congruent to JKLMNO. Okay, that is all I have for congruence and similarity today. Make sure you answer the questions listed on Delta Math after this video. Thanks, you guys.